All right, we're good. I think we're ready to go, you know.
Cool.
So here we are again, and nice little holiday weekend.
Yeah, welcome back, fan addicts. Hope you guys had a great Thanksgiving, Black Friday. Hope you got some good deals.
I know it's like, dang it, it's upon us.
Oh yeah.
So cool. Well, what'd you do this weekend? You know, we always start out.
That's true.
If you didn't do anything, what do you wish you did?
Did a little bit of Black Friday shopping. I went to, they did like a luxury sale where they have a whole bunch of like super high-end luxury stuff, but at like 80% off the tag, which is already 50% off the store. And somehow I found a full suit. It's a really nice suit. And my brother's like, dude, that fits you perfectly. And I was like on the fence, like, I don't know if I should get it. And then he was like, no, you have to get this. This is an insane deal. So I got a new suit, and it's really nice. So I'm stoked on that.
Cool.
Yeah. How about yourself?
You know, we had a nice Thanksgiving with the family here in town. We always kind of split the day between my family and my wife's family, so that's all good. And headed out to the desert. We actually went out by Lake Havasu in Arizona and did some off-roading in the buggy and did a poker run. We camp at one of the Indian casinos over there on the California side, so it was nice.
In that big like empty plot of land there, is that what I'm thinking? Next to the mountain.
You got a whole lot of desert all over the place out there. So it's, you know, you've got like Lake Havasu where you have London Bridge that's that's the Arizona side.
Right.
And we stay actually across the lake on the California side. So it's called Havasu Landing, and it's all Indian land over there. But yeah, they have their casinos and stuff. So it's a great place to go play in the dirt.
Awesome. Do you smoke a turkey this year?
I did not have to cook any meat. So all I had to do was show up and eat it.
Lucky you.
So I got to do a little carving and eating this year. So
that's a pretty good gig.
Every now and then I'll let the other guys do all the cooking.
Cooking, cleaning up, you just show up.
I had to get all the gear ready to go and, you know, getting the rig packed up and getting everything out, and the kids took their motorcycles and stuff.
So they handled the food, you handled the fun.
That's right. That's how it went down this weekend.
Cool. So what are we talking about today, Charlie?
You know, we're just going to talk about some different variations of blowers and, you know, how they're used and where they're used and things like that. We've got a couple little samples here, so I'll just kind of share as we're talking through some of the different things.
Yeah, so my first question is, when does the design or application actually force an engineer to use a blower as opposed to a fan?
Yeah. A blower over a fan, the key technical difference is the pressure that's produced.
Right.
Right. So, you know, you've got, and plus obviously a blower is very different looking than a fan. So just a quick reminder after our blower ABCs, right? A blower, instead of being axial, is radial.
Right.
And we talk about radial disbursement of air, and that means that it's sucking the air in the top here, right, and then dispersing it radially. So, you know, you get a 90-degree airflow pattern versus like a fan. If this was a fan, right, it would be blowing left to right, you know, axially. So, but blowers put out a lot more pressure. You know, I'm a car guy, so my analogy is it's kind of like the difference between having a gas engine and a diesel engine. You know, gas engines aren't notoriously famous for high torque. They're higher RPM, you know, all that. Whereas like a diesel engine that's in a big rig or something, right, they're lower RPM, but higher torque just by motor design, right? So you get different features. So that's kind of what we're talking about today. You know, which application do you need a blower? Because a fan won't even get it done. So when you're saying what applications need it, it's higher pressure systems. That's the simple answer.
So you mentioned higher pressure. So let's talk like a higher heat load. And when that's concentrated, which blowers would be the best for that? Like if there's a heat load hotspot.
Yeah, so you know it's not that a blower is going to make a hotspot cooler. The key is getting enough airflow over it. So if you're in a high pressure system, a fan is not going to push as much air as what a blower would.
Right.
right? So the whole thing is it depends on if you're talking about small devices that are very compact, we're gonna have stuff like this, right? I brought in a big one because it's a little bit easier to see. This is a prototype we did for a customer. That's why it's white. But this is modeling or prototyping plastic. So, you can see inside, it's like we've got a very similar device as this inside this housing, right? And so really it all comes down to how much flow under pressure you can get. So that's why a blower is going to do a better job in a high pressure system.
Got it. And then when does ducting automatically push an engineer towards a blower?
Well, you've stated why they would need a blower, because fans do a very poor job of blowing air through a duct. Right. So when we're talking about ducting, we're talking about tubing, piping, ventilation. We'll do a simple one, right, that everybody's familiar with is like HVAC, right? So when you look at HVAC in your building, in your home, all those systems would always have a blower in there, because you cannot get enough pressure from a fan to be able to blow air through all those ducts like in your home or in a building, right? And so, it's just by design they're able to push more air through the system.
My understanding is that they're really good at pushing air if there's, let's say, multiple turns in a system. How would an engineer look at their system and say, okay, we don't need a few fans going different directions here, we would actually prefer blowers?
Yeah, and that's when you would design a well-flowing duct system, right, versus having a couple of fans in a different spot. Like if you wanted to have, again, going back to HVAC,
right,
one unit is supplying air, like we'll just say in our building here, we've got like 6 offices, a sales room, a lunchroom, all that. Well, it's one AC unit that takes care of all that, right? So when you get into the design, and if you do choose to use ducting, that's something that we could help with at YS Tech and do simulations and tell you what the best optimal design is, right? It's like I can't just say, oh, well, go buy a 4-inch pipe and do this and don't do a 90-degree turn, but those are things that you work through and look, you could do simulations on. Then that way you can find out, going back to your hotspot question, you got to identify how much airflow you need to cool that hotspot first, right? Once you know how much airflow you need, then you look at the ducting, identify how much pressure is produced in there, then you can design a part that will tell you how much airflow is going to go through there. Now, if you go back to the ABCs part, what would we call that?
Gotta put me on the spot like that.
That would be called our operating point. Right? So we gotta be able to identify our operating point to be able to identify the airflow. So whether we're doing ducting, no ducting, just a box, it's always identifying all your circumstances to be able to identify the right part without just trial and error.
So you mentioned high pressure is a lot better with blowers. I wanted to ask you, is there a certain threshold that engineers should be looking at in terms of pressure they need where they should be looking for a blower?
I would say that in your standard fan line, axial fans, right, if we're talking about, like, let's just standard products. Fans in those ranges, like if we're talking about fans under 80 millimeters, those fans only produce, you could have half your line that's only producing less than a 1/4 inch of pressure. Or we'll talk millimeters since all our specs, like, 6, 7, 8, 9 millimeters of pressure. You get into some of the bigger fans, 80s to 120s, those guys can range in pressure characteristics from 5 millimeters up to maybe 17, 20 millimeters of pressure for a normal fan.
Right.
So, okay, that's cool. But then you get into like what we call our edge computing and high performance fans. We do have axial fans that have those airflow straighteners on them that are very high pressure, right? And those fans can range from 1 inch to 4 inches of pressure. Right? But those are going in very specific devices that are designed to have axial airflow. Right? So if you say, all right, what is the threshold for blower, pressures, like if you have a backward curved impeller like this, you would need this for pressure loads greater than 1 inch of pressure, which is 25 millimeters. So to answer your question directly, how much pressure? I would say once you're getting north of 1 or 2 inches of pressure, a blower could be of consideration.
Got it. And then when do you usually see blowers being chosen because of those tight airflow areas where they need a high amount of pressure?
So I'll give you probably one of the, well, for us, one of our highest volume examples, and that would be seat ventilation in a car, right? So just think of it as being like a device, right? I know everybody doesn't make seats, but think about it. You put a blower in there and you're sitting on your seat and you still want air to be coming through, right? And so inside your seat, there's actually a very elaborate ducted system that's soft, right? And that's what actually will push the air through your seating and all that. So, but some manufacturers do use fans, and they have a very specific design for their internal vent bag, they call them, to be able to accommodate that pressure that a fan would produce. But most are always blowers.
So you would say that's usually when there isn't an application for a more open airflow, more so for a tight ducted airflow.
That's right. And it all comes down to your operating point. Some people could design, if we had a box that was 1 foot square, depending on how many circuit boards and things you had in there, you might be able to have a 120 millimeter fan on there that's a nice little 80 CFM and, with a 1/2 inch of pressure and do you just fine. But then you might want to have a hot rod box that has twice as many boards in it with twice as much pressure. Then you either got to go to a blower or one of these high output fans, the edge computing, that have those 3 or 4 inches of pressure.
And I wanted to ask you about specifically ramping up blowers and how, let's say someone were to buy a blower, how could they ramp it up? And then also what applications would they need to ramp it up?
So, a great application, or, everybody uses, it would be a laptop, right? We're not into laptops, but I'll use it as an example. So in your laptop, there would never be a fan, right? Because think about it. Your laptop is it's not even a 1/2 inch thick, right? And when it's open, it's like super skinny, right?
Right.
You couldn't even put a fan in there if you wanted to, right? Because it has to be flat.
100%.
And so all laptops have blowers in them, right? So you have a very ducted system, and you say, well, how in the world do they put a duct inside of a laptop? Well, when you get in there, it can be we'd call it a thermal module or a cooling plate. And literally you would have a plate that would act as a heat sink, but then you can machine channels and stuff in it. All those will create airflow patterns, to where you can be dispersing air in all directions within the unit, and be a very unique setup. So, real estate always affects how you can have your orientation in there, right? Because some people don't have the ability for the fan to blow left to right. They may say, I can't even use a fan if I wanted to, because the only option I have is I need a 90-degree airflow. And so all those things are things that we love to talk through with you if we sit down and look at your design, or, help out on the operating point, because when you get into the higher pressure applications, that's the number one thing that happens. When I say happens, the issues arise, whether you have enough high pressure, low pressure, and a fan that can accommodate it and have the right current draw. But back to when you say ramp up, what we apply to that is like a unit there, we can have PWM on it.
Right.
I keep pointing over there because my laptop's sitting over there.
Yeah, no, fair enough. Makes sense. Now
You can't see it, and I keep doing that. So anyway, that's what I'm pointing at. But you have a ramp up on it with the PWM, right? Because you might be sitting there working on your laptop a lot, and you're doing emails or surfing the internet or whatever. You don't even know if fan's in there, right? Maybe you start working on some stuff, and you're in Adobe and modifying some videos and doing some advertising for your gig and whatnot, right? And you hear a fan kick on. Well, the whole beauty of that, right, is that you have the PWM to ramp up the speed of the fan as you need the load that's being produced on the system.
Yeah, usually when that happens, I'm just like, oh, my computer needs to take a little chill pill.
No,
You'll
you're just
be
giving
vibing
it.
and just.
Yeah. So it's when it's working. So if you were in a power supply, right? Think of that like, half the time if you have a device, and the power supply sitting there and you're not using it a lot, well, and it's not hot, there's no need for the fan to be running.
Right.
But if you're doing whatever it is you're doing, and then or like you're a power supply on charging our cameras, right? Well, when it's actually charging, it gets pretty warm.
Right.
Right. And so PWM's a great thing. You know, it's I would say that more than probably 60% of our business is with PWM these days. And, you know, it really makes everything a lot better on the controllability. So we can go from standard blowers with PWM, the backward curved impellers. This is a DC model. You know, this guy here goes in an EV charger. You know, so it's like you look at those and you're like, well, why wouldn't they want a fan? Well, it was at the top, and what blowers do well too is they're good at sucking air, right? So sometimes you're not always blowing air on stuff, but you're actually sucking the heat out of the unit and then dispersing it. So like telecom cabinets and stuff like that, that's what those are used for versus blowing through ducted systems. So they can go either way, pressurizing systems or, you know, removing the air.
Got it. And then we've spoken a lot on this podcast about the future of technology. So I wanted to touch on, where do you think the future of blowers is actually going?
You know, there's so many different versions of it. You know, if you look at the industrial world, the evolution is going from AC to EC or DC, right? So when you talk about all these different rotor designs here, you know, sure, you get fancier, but you know, that's how you produce your airflow, and it gets more into motor technology that's in there, and that's helped bring down the power consumption, you know, the controllability, the temperatures that they can reside in, the vibration they can withstand. So, you know, we feel like when we say the future, we're becoming more and more educated on the needs for all those different types of industries that have extreme conditions. And those are the kind of things that we like to look at versus just a lot of your standard applications, because we feel like we can bring more value in the specialized goods.
100%. Is there anything you want to add to our viewers back home?
No, hey, we're just glad to be back to work this week, and we're getting the blower thing going, and we're coming up quick on the end of the year. So we're going to try and keep our pace going with the regular weeklies, but we've got a couple travel trips coming before Christmas, and but we'll make it happen and get it out there for you.
Yes, sir. Hey, thank you guys so much for tuning in. Stay fan addicts. Hope you have a great day.
That's right. Keep it cool.